everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire, and today we've got Enzo, who has just completed the course ROS2 Basics using Python, and he will be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so that he can begin his presentation. Alright Enzo, whenever you're ready.
Okay. Hello everyone, welcome to my presentation. My name is Enzo and today I will show you my ROS Basic in Python project. So in this presentation I will do a demo of the robot's behavior, and I will talk about the three different algorithms that are implemented in the robot, which mean the wall finding, the wall following, and the odometry recording. So for the wall finding logic, basically it splits in three parts. The first one is that the robot is looking where is the nearest wall. So to do so is using its scans to see where is the lowest value, which means that an obstacle is the closest. So this is the search mode. Then it will turn on itself to face this value. So for example, if the closest value is on the right of the robot, it will turn on itself until the front value was the lowest value detected. So which means that it is facing the wall. Then the second step begins, which is approach. So basically the robot is moving forwards to until a certain safety closeness is reached, which is the 30 centimeters. And then the last part is the turn part, where the robot is turning until its right value matches the previously front value, which means that basically a 90-degree rotation has been made. Algorithm stops. For this part, I encountered two different issues. The first one is the difference between the simulation and the real robot. I think that the simulation has less sensors as the real robot, but the real issue was that I think there is a wire or something like that at the back of the real robot, which means that there is always the lowest value is always behind the robot. So when I tried my algorithm, my robot was like looping infinitely. So the solution for me was to just look in front of the robots and on the right and on the left, maybe like 120 degrees in front of the robot and like in the back of the robot. And the second issue is the rotation speed, because if the rotation speed is too high, we may not enter in the, if you can see the last condition in the turn else, like if the right value is between self front value minus 0.5 and self front value minus plus 0.5. If the rotation speed is too high, we may, for example, if the right value is 1, we may go from 0.5 to 1.5, you see, and we may not enter in the condition, so it could turn infinitely also. So I had to play a bit with the values to keep it consistent, and I also wanted to have not a rotation speed too slow, because I wanted to try like a real condition robot. We want to be moving like not too slow. So it was a little challenge to me to do so. For the wall following algorithm, it's basically the same as the second part of the wall finding. So the robot is moving forward until an obstacle is detected, and then it turns on the left until the right value matches the front value. The differences are for the following parts. So I made sure that if the robot is too far from the wall or too close to the wall, to adjust his trajectory.
Mm-hmm.
And also I tried to keep it as most as parallel as the wall possible. So that's the condition with absolute value, mean right index and right index, just to be sure that the robot is parallel. So we will see on the demo that sometimes we can see the robot moving a lot just to try to stay parallel, but
Mm, mm.
I kept a high speed value, so that's why it would that be easier with a slower
All right.
speed.
Okay, so that's interesting. So you're saying if your robot is going a lot faster, does that mean it doesn't correct aggressively?
Yeah, no, if the robot is faster, obviously when it adjusts, it may adjust, it may have to adjust back, you know. If it's very slow, we can easily turn on the right and then stay straight. But if
Oh,
it's
okay,
fast,
okay.
it may turn on the right and then okay, I'm too much on the right, on the left, on the right, like that. You see.
Okay, so it oscillates. Okay, all right,
Yeah,
makes sense.
oscillate exactly. So here also I encountered different issues. So the same as the wall finding, the rotation speed, if the rotation is too high, we may never enter in the condition.
Mm,
And the second one is pretty interesting, and also it seems obvious, but it took me a lot of time to understand.
mm-hmm,
So basically, when I was trying on the simulation, the robot was working quite fine. Just sometimes some glitches may happen where the robot was like stationary, but turning on the right, on the left, on the right, little glitch. And then I tried on the real robot, and the robot was not moving at all.
mm. So were you
And in
able to
fact,
understand what was going on?
yeah, and it's very obvious. In fact, I understood when I logged the velocity topic, and I saw that the wall finding algorithm and the wall following algorithm were both publishing on the topic. So the wall
Okay,
finding was saying, okay, go on the right, and the wall following was saying, okay, go on the left.
okay. So what
So
did you fix?
what I've done is that when the wall finding job is has ended, so basically when the state at the end, the state we are in the state follow,
Mm-hmm.
I'm subscribing the wall finding algorithm to the velocity topic, so it won't publish anymore on the topic.
Mm. So does
And
this mean
basically, I end it
okay? Does it mean you were not using state machines before?
before. What do you mean on the before?
So when you realized that you were both
Oh yeah, yeah. So sorry. Yes, I was using state machine, but the I was not as it's a different service. I was not unsubscribing. It was keeping subscribing even if the oh yeah, I understand the question, because in fact even if the self state was follow,
mm-hmm.
I was creating the action with linear and angular at 0. So it was publishing 0. Although every time it was publishing 0.
Okay.
And so one solution would that be that it the we avoid the publishing, but I find out that just unsubscribing the robot, the wall finding was an option logical, because we don't need anymore this algorithm, so we can just like shut it down
Mm.
on the
So
robot.
yeah, that's the whole idea of using a service, right? You want to call it once only when you need it, right? So
Mm.
are you saying you were calling it more than once?
Nope, only at the beginning, but I think uh, I don't remember if we could see on the code after, but don't remember if it's the wall finding that is the service of. or it's the wall following. We will see later, but okay. So I don't know. Okay, so I may have forgot that. Okay,
All right, so let's
so I
see
don't
the
know why
demo
it was
so we
keeping.
don't run out of time.
Yeah, I will see the demo, and after that I will talk about the odometry if you
Sure,
want.
sure, yes.
Up. Yeah, so the wall finding service was not ending properly, which make that's why it took me time to understand.
Okay.
Okay. Up, up. Okay. So as we can see, the first step is for the robots to. Okay. Okay. So basically, it thought that the obstacle are. Okay. Okay.
Yeah,
Calm down.
I was going to ask you about this, right? So, clearly you didn't put a guide for this, so we want to talk about this a bit later. So, maybe let's have it in a position where the wall is the only thing that is probably as close to it as possible.
Yeah.
All right. So, is it running yet?
Yeah. Is it running? So
Okay.
as you can see at the beginning, he may have turned a bit too much.
Yeah.
It's because I told him to try as much as possible to turn on the 90-degree. But if if the robot is not straight in front of the wall, it may just turn a bit too much.
I see. All right. It oscillates a
You
little
can see
bit, but
yeah, we
I
can
think it's
yeah,
following
we
it.
see that. Up. Okay. And so now it matches the odometry
Ah,
part.
perfect. Okay.
So we see that the robot did a whole loop. And what I've done is that once the loop is done, we just shut down the wall following process.
And can you
So we
tell
can
me
see,
a bit more how you managed to do that? Like, how does it know that it has arrived, and what are your tolerances
yeah,
like?
yeah, exactly. And up, it's here.
Okay.
So
Maybe let's maximize that. Yeah, sure.
up, up. So basically, how it's working is at the start of the wall following logic, I'm also starting the odometry recording.
Mm-hmm.
So to have the origin point. And basically what I've done is that once the robot re-enter in this origin point, it ends the recording and it ends the, the working of the robots. I
Okay.
tried I tried to keep the 5 centimeters um, area,
And how did
but
that go?
with yeah. So yeah. I it was not working because obviously the robot as the speed and the oscillating of the robot, it
Yeah.
was like never reaching the value.
Yeah, it would oscillate out of
Um,
it, right? Or it would miss it completely
yeah,
because it's so
exactly,
high.
exactly. So but I know what I will talk about it in the next slide.
Mm-hmm.
But so I increased it to like 30 centimeters,
Okay, so
and
that's 15, 15 on either side. So 30 in diameter, or
uh,
because I'm thinking if 30 is your radius, then that means like 60. 60. I mean, point 0.6
no,
of
I
that
don't think
is the
it's
size of the circle, so
uh,
that's a very big zone.
And let me check.
Mm-hmm.
That's a good question. Um, up, 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 up. So it's here.
Mm-hmm.
Dist to origin. Yeah, so
That's
it's a
basically
distance.
your
So
radius.
yeah,
Okay.
it's
That's
a
huge.
radius. Yeah.
That's huge.
Yeah, I
So,
did not thought about that. Yeah, I did not thought about that.
and can you tell me how you dealt with the problem of the robot starting and then wanting to stop? Because that zone is very big.
Which one?
So when it starts moving, right, it obviously recognizes that it's still within the zero point 0.3 meter radius, right?
Oh yeah, 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 yeah,
So
yeah,
it's asking
exactly.
for
So
X to
I made it
close to
here.
you. Okay.
I made it here. I made sure that the total distance may have maybe more than 1 meter.
Okay. So it has to be more than one. Okay, I see.
Yeah,
Nice, nice. Okay. Let's go on.
and and so so that's basically how it's working. And then at the end, it returns the total distance traveled and every points that were recorded.
Mm-hmm.
And so what could be improved in the short to mid term?
Mm-hmm.
The first one would be obviously the odometry recording. We could what a good solution would be to, instead of looking the points of the odometry, would be to do some calculation using the triangulation, for example, knowing the size of the robot and to know its position and knowing where is the origin point and what's the distance traveled, we could calculate and determine if the robots uh, uh, like went through the origin points, even if the odometry, even if the robot was fast and the odometry recording was not exactly as the origin point. So like to determine, to calculate if the robot did the loop or not. And another improve would be to use the PID controller to be sure that the robot is not oscillating, just to be sure that we are parallel to the robot and we do the right rotation, not sometimes too much, as I said, like the 90 degree.
Okay.
And
So
yeah.
yeah, let's talk a bit more about the your suggested method of improving odometry recording, right? So you spoke about triangulation. So to triangulate, you need 3 points, right? My assumption is the first 2 points are going to be your robot. I mean, your robot and the point of origin. What's going to be the third one? Am I understanding you correctly there, or?
Yeah, so maybe the word triangulation is not yeah, because triangulation is using angles. So maybe we could do it. I don't have the mathematical brain for that, but so maybe that's not the right word. But I would say that we could determine according to the robot position and the road position, the trajectory, the speed of the robot, and the origin point. We could determine if the robot traveled across the origin point or not.
Okay, okay, because I'm
You see?
reading through the point, your point here. So it says improve origin detection reliability by using LiDAR scan, matching,
Hmm.
or okay, LiDAR scan matching or triangulation to identify the starting point based on environmental features rather than raw odometry alone. Okay, yeah, okay, it makes sense. It makes sense. I see that it's an idea which came across in your mind as a way to fix this, and uh, maybe you didn't dig deep into it as much, but yeah, it makes sense. I would say that's good. So now
Yeah,
let's.
because
Yeah, go ahead.
just to have some context, in the school I worked on the IoT and I did work on certain robots, but
Mm,
not with ROS, and we did some mathematics about that. Like a robot had to follow a certain white line,
mm-hmm.
and we had to do some calculation. So that's why I thought about that.
Yeah. Now, what I want us to speak about in a bit more detail is, you remember we spoke about using a service to find the wall, right? So, can you show me
Yeah.
your script, your wall finding script? Because I want to understand how are you doing it, and then maybe you can explain along as you pass it through.
Yeah. Okay. So it begins with the laser scan.
So
So
excuse
basically,
me,
where I'm.
uh,
Oh, yeah. Sorry.
call it full screen, and
Yeah,
then
like that. And
yeah, that's good.
can
That's good.
can I
Yeah,
zoom in? Okay.
yeah.
So in the init, obviously, I'm subscribing to the laser scan because I want to have the lasers data to work with. So I'm then entering in the callback. What I'm doing here is, as I said, I'm looking for the nearest point with the following scans, so in front, on the right, and on the left. So the range I was talking about.
Yeah.
Yeah, and I use it as the initial nearest because obviously, if I'm turning around, the nearest will always will never be on the same indexes of the array because I'm moving. And then this is the states as we saw. So the search, the approach, and the turn. And this is the part that I told you where I am stopping the subscription to ensure that no more how to say no more action is published.
Okay. Okay. So let's stop
So
here on this wall find. Okay. So right. Okay. I see. I see. Okay. Yeah, you can go and explain more.
so maybe it's now that the project is working, maybe it's just a extra kill. But at the beginning of the project, I needed this to work. Maybe if I just delete this part, is now working as the because the service is like ending properly. But
Yeah. So
at the beginning of the project, it wasn't.
what's a bit interesting to me, and what I'm also trying to understand is, you are calling your subscriber one more time. Yeah, I have to think. I think I have to think about that a bit. I can see that when you when you then call wall found is just going to send a true or false, right? But wall found is using the function that's above it, which is basically the one that subscribes to later scan data and then using it to find the wall and then setting the boolean value to true or false, right? So I'm trying to understand what was your exact problem with this, and also why is it that you need to like kill that subscriber. Okay.
Because the wall find just put the state at search. So then it begins the activation of the laser scan because until the state is search, we are in the waiting state.
Okay, in a way. So you wanted to be sure that you exit that state and you exit without it doing processes that you're not so sure of, or doing processes that will
Yeah,
affect. Okay. Okay.
exactly. Yeah, exactly.
Okay. All right. Very, very wonderful presentation, Enzo. I really loved it, and I hope all those who will watch this or are watching are also going to learn a lot about this project. And job well done on this one. So congratulations to you.
Thank you very much.
Alright everyone, this was Enzo's presentation, and a warm congratulations to him. And to all those of you who would want to try this project and also come and make your presentation,